Hello and welcome to the first lecture in our new series. In this series, we're going to talk about chromatography. We're going to discuss different techniques and how it works and its applications. But before that, let's learn some of the basic things about chromatography. Chromatography basically is a separation and purification technique. We need to learn certain important terms before we go into the details of this technique. The first thing that you should know about chromatography is the chromatogram. So, chromatogram is basically a layer with separated components, or it might be a response to a detector. So, it's a layer upon which the experiment is carried out, and it shows all the components of a mixture, whether in separated form or in combined form, or in some of the modern techniques, it may be known as a response to a detector. In chromatography, we use different phases. One of these phases is a mobile phase, the other is known as a stationary phase. As the name indicates, a mobile phase is a phase which is movable. This is the phase which moves during the experiment, and on the other hand, the stationary phase is the phase that remains static, it's immobile or immovable during the experiment. Now, the components of the mixture, they get separated because of interaction with the stationary phase or the mobile phase. So every component spends different amount of time depending upon their affinities with the mobile or the stationary phase. So we record or report our result in the form of the retention time, which is the time a component spends on the stationary phase. We may also record it as a retention factor, which actually is the ratio of the time spent on the stationary phase and the mobile phase. So these are some of the important terms that you need to know before going into the details of chromatography. So as I told you earlier, chromatography is basically a separation and purification tool. And based on this definition, we can classify chromatography into two types. One is known as the analytical chromatography or analytical chromatographic technique, or chromatography can also be preparative. Now, when it is used for analytical purposes, it's basically just the analysis of a mixture. So we have a mixture, we carry out chromatography on an analytical scale, and we analyze the mixture because we just want to know how many components are there in the mixture, what is their retention time, what is their retention factor, what is the relative flow of these components of the mixture. So it's just analysis of the mixture. But if you want to really use it as a purification tool, then you have to carry it out on a preparative scale, and that means that we can actually purify the components of that mixture. So the basic difference between these two techniques is that in analytical chromatography, we need or we require the sample in a minute quantity, but for preparative chromatography, you can inject or you can apply your sample in large quantities. And that is when you can actually obtain these components in pure form in bulk so that you can analyze them further. We can also classify chromatography depending upon the phase. So let's see what are the different types of chromatographies depending upon the phase. So we can classify chromatography as a normal phase chromatography or reverse phase chromatography. So let's see the difference between the two. In a normal phase chromatography, the mobile phase usually is less polar, while in a reverse phase chromatography, a more polar mobile phase is used. So in a normal phase chromatography, the mobile phase that is used is usually a pair or a mixture of two or three different types of organic solvents, for example, N-hexane, which is a non-polar solvent, or a slightly more polar solvent like chloroform, trichloromethane, or ethyl acetate, or acetones can be used as a mobile phase in normal phase chromatography. But in reverse phase chromatography, the mobile phase is slightly more polar. For example, methanol or water or mixture of the two can be used as a mobile phase in reverse phase chromatography. The stationary phase in a normal phase chromatography is more polar than the stationary phase in the reverse phase chromatography. So usually silica is used in a normal phase chromatography experiment, but for a reverse phase chromatography, we usually have less polar stationary phase. That could be a C18 silica, or we also known as RP silica, reverse phase silica, which usually is non-polar because a long chain of hydrocarbon is attached to the silica. Like for example, in C18 silica, 18 carbon chain is attached to silica that reduces its polarity. Now, when we carry out a normal phase or reverse phase chromatography, what results can we expect? So, in a normal phase chromatography, as you know that we have a less polar mobile phase and a more polar stationary phase. So that means that the less polar compounds or less polar components would be happy to travel with the mobile phase because that is less polar. And the more polar compounds or the more polar components would be happy to stay with the stationary phase because of higher affinity with the polar stationary phase. That means that uh, because of larger distance traveled by the less polar compounds with the less polar mobile phase, they will have a higher RF value. And because those more polar components are happy to stay with the stationary phase, so they will not travel a lot with the less polar mobile phase, meaning they will have a lower RF values. So less polar compounds usually have higher RF values in a normal phase chromatography, and more polar compounds will have a lower RF values. But in a reverse phase chromatography, the less polar compounds, which are reluctant or which would be reluctant to go with the mobile phase and would be happier to stay with the less polar stationary phase. So that is why they will have a lower RF value, but uh, but the more polar compounds would be happy to travel with the mobile phase, and that is why they will have a higher RF value. So that is the main difference in terms of the results obtained in a normal phase and a reverse phase chromatography. So these are some of the basics of chromatography. In the next sessions, we will talk about the different techniques, or we will talk about the different chromatographic techniques used for analysis or purification of different components of a mixture. So thank you so much, and stay tuned for the upcoming lectures on chromatography. See you later.